I'm Anil Kumar sharing with you a question from the textbook Nelson Advanced Function Unit 6, 6.6 Modeling with Trigonometric Functions, question 8, page 361. It is for my subscriber Ellen. A contestant on a game show spins a wheel that is located on a plane perpendicular to the floor. He grabs the only red peg on the circumference of the wheel, which is 1.5 meters above the floor, and pushes it downward. The red peg reaches a minimum height of 0.25 meters above the floor and a maximum height of 2.75 meters above the floor. Sketch two cycles of the graph that represents the height of the red peg above the floor as a function of total distance it moved. Then determine the equation of sine function that describes the graph. So I have a very limited space. So what I will do here is sketch and then write the equation in the same space. So I'll use colors so that we don't really mess it so much. Okay, so let's begin by the spinning wheel itself. And let us say this is the wheel for us. Okay, so what we are given here is that the wheel has a red peg which is 1.5 meters above the floor. So let us say this is floor. Okay, so let me just extend this floor. We'll draw the wave here. And this red peg is 1.5 meters above the floor, and it goes 0.25 minimum and 2.75 maximum. So this height for us is, let me write here, 0.25, and the maximum height for us is 2.75. So let's find the center of these two first. Okay, so center you can get by adding them, 2.75 plus 0.25, and then divide by 2. So that gives you 3 over 2, and 3 over 2 in decimals is 1.5. So the center here is 1.5. And fortunately for us, the red peg is 1.5 meters above the floor. That means it is right there in the center, right? So you can see the wheel here. So from the floor, that's the lowest point, that's the axis, and that's the maximum. Now it says that sketch two cycles of the graph that represents the height of the red peg above the floor as a function of total distance it moved. So we are pushing it downwards, right? So when we push it downwards, the height decreases. As it reaches at this place, it is the minimum, then it increases. So that is how the graph should be. So let us now try to sketch the graph itself. So for my graph, let's say this is y-axis, and the floor itself is the x-axis, right? So this is my floor, which is the x-axis. Correct. Now, axis of the graph will remain right there, right? So this is at the height of 1.5, so I'll have axis here. So let me draw this axis for the sine wave. Maximum, it can go to 2.75, so I'm drawing a dotted line here, 2.75. It will help me to guide, and minimum is 0.25, so that is my minimum for the sine function at any instance of time. Roughly, let me sketch a graph here. So, okay, let me use this color. I want to use light colors so that I can draw in dark. So when you are starting from here, at that time the peg is 1.5 above the ground in meters. So it goes down first. So we have the cycle which is going down, then up, maximum, down, like this. So we have to sketch two cycles. Let's sketch two cycles like this. It goes up. So that completes one cycle, right? And then goes again up and then comes down. Okay. So one cycle is up to here, the second cycle is up to there. So that is how it goes. So we have sketched 2 cycles, correct? So that is how we can sketch 2 cycles, and as you can see, the axis will be at 1.5, maximum will be 2.75, and the minimum will be 0.25. Now what is the distance? We are having distance along this side. So the distance will be 2 pi r. So we need to find what is the radius of this, correct? Now the radius will be the average of these two values, correct? So let's find the radius. So we'll add 2 point. So let's find what is the radius. So distance from here to here, diameter is 2.75 minus, so 2.75 minus 0.25 gives us the diameter, and divided by 2 gives us the radius, which is 5/4. So 5/4 is the radius for us. In decimals, I can write this as 1.25. So the radius is 1.25. So that is the amplitude. Is it okay? So in this case, when we are trying to write an equation, well, we are going to write equation in sine form. So let me write down the general equation of sine graph here as the height as a function of distance, right? So the height will be, let us say h is the height over distance d. Then in general, a will be the amplitude, sine function we are talking about, right, times k, and let me write d minus c plus, let us say a k value, or k we use, let us say h value, the initial difference. Okay, so that is the equation we are looking forward. In this, a is what? Maximum minus minimum divided by 2 is a value, which we just found, right? So we'll write down in this, a equals to maximum minus minimum divided by 2. So for us, we calculated it was 2.75 minus 0.25 divided by 2, and this equals to 1.25. So a is 1.25 for us. We need to find what is the distance moved in one circle. So we found 1.25 as the radius. So from here to here, that is one cycle, we need to find what is the distance. So that is 2 pi r, correct? So this distance is 2 pi r. So let's do 2 times, radius is 1.25. So 5/2 pi is, we can write this in better, we can write this distance. One circle is, so we have one full circle, that is time period for us. Distance moved is 2 pi r, right? 2 pi times r. So r is 1.25, that gives us 2 pi times 1.25, and that is equals to 5/2 pi. 5/2 pi. I prefer to use fractions, since when we find the value of k, which is reciprocal of distance, it helps, right? So now let's find the value of k. We know d, one time period along this, right? So k will be 2 pi over this distance d. One full cycle takes a distance of 5 pi over 2. So we'll replace this d by 5 pi over 2, right? So we get 2 pi divided by 5 pi over 2, right? So pi and pi cancels, and we get 4/5 as the value of k. Do you get it? Okay. So we get k also. As far as the phase shift is concerned, we can say phase shift is half the cycle, or we could say that a is negative. It is reflected on y-axis. So that can work. And h is the axis itself, which is 1.5 meters above the ground. You get the idea, right? So we know all of the values. So k is 4 over 5. Now h is the axis, which is 1.5, correct? Knowing all this, we can now write down our equation, which is h of d equals to minus, since the wave starts going downwards, amplitude is 1.25 sine of k, we calculate 4 over 5, distance d, right, minus c, because c we took as 0 and put minus here, plus the axis, which is 1.5. So that gives us the equation for this sine wave, which models the given situation, right? So I hope you understand and appreciate how to do it. It is kind of important to understand that in such cases, the independent variable is the distance along the circumference. Based on that, the height of this peg is changing, right? So h of d equals to minus 1.25 sine 4 over 5d plus 1.5 represents height of the peg in meters, right? So that is how you should be doing it. I hope it helps you to understand the concept. Thank you and all the best.